So someone asked for 1.4, slide number 4 and slide number 9. So we'll go over that really quick. I already have the answer on our notes. It's right here. The answer is 21 push-ups. But in case you want to see why it's 21 push-ups, that's what I'm going to do over here. So the very first thing that I notice here, and maybe this is something that you see, is you see this is jumping up by 2s, right? So this is +2, and this is +2. And then this is +2. And a lot of you came up with really good ways of figuring out that the answer was 21, right? So, and actually I'll show you. So some people did, oh, you can kind of see, this person did. I know that it's going to be 21 on day 10 because it's 10, wait, it's 12 plus 9, and the 12, right? We get these sets right here, and then the 9. So this, it looks like what this person did was they started with this right here, this 9 right here, and then they added the 2 push-ups for every single day, which if you think about from 4 to 10, that's 6 more days. So that's 6 sets of 2. So that's how this person calculated, right? Really good job. Another person, I remember seeing another person doing something different. It was this person. So yeah, this person kind of did the same thing. So 9 plus 2 is 11. They did the 6 more days, right? There's another person who did something different, which I really appreciated. Hold on a second. Oh, this person. This person is kind of coming up with the formula, right? And they say, hey, Ms. Johnson, I'm gonna add 2 push-ups per day. So that's 2 times 10 plus however many push-ups I did on quote day 0. So if you think about the way Noah, I keep bringing it back to Noah because Noah was the one who first talked about it. If you think about going backwards, so if this is +2 plus 2, then to get the 0, how many push-ups is he doing on day 0? Well, if this is +2, go backwards to go here, and it's -2. So this would just be 1 push-up right here, right? So that's where this one is. This one right here is that one right there. This is really messy, Ms. Johnson. And then this 2 here, let me highlight this 2 in green. This 2 right here is the new 2. New 2 here, +2, +2, +2. So this is that explicit equation over here that we got, 2x plus 1, right? So there you go. Okay. Someone asked about the recursive equation, because if you just look at the next slide, it asks, now model it using a table graph, right? Both the recursive and explicit. This is explicit. Explicit means that you can plug in any random number. So if I said, okay, well, how many is he doing on day 30? You could just plug it in, right? Recursive is you knowing how many to add to the previous day to get to the next day. And remember, we talked about, you could also write this as previous equals, next equals previous plus 2, right? So in words, if I was going to write this, this is next equals previous plus 2. And why is that true? Because that's what you told me over here, this green +2, +2, +2. Most of you have that +2 going down, like +2, I see +2 here. I see some indication here. I'm seeing some indication here. By the way, when I'm grading your work, I'm looking for indications of you understanding it. So this tells me that the person knows how to find the slope, the rate of change, whatever word you want to use right there, right? So that's where our +2 comes in. And remember, we talked about how +2, he's the main star. He's the +2, +2, +2. You see him over and over and over again in both. Okay. The other part of the recursive is you have to tell me your starting point. In this case, on day 1, let me scoot it over so you can see what I wrote here. On day 1, 1,3 is your work, right? On day 1, Scott did 3 push-ups. So that's what that says. Okay. Okay, next one is number 9. And then I did see your chat for number 13. So slide 9, this is always going to be, whenever it says this is a takeaway. I don't need you to do anything, but this is something that you should be a little bit more versed on, meaning that you now know how to find the difference in each equation representation of an arithmetic sequence. That's the +2, +2, +2. You do know how to do a table. Absolutely, Ashley. You do know how to make a table. You know how to do an explicit equation. You know how to do a recursive equation. And you even know how to do a graph. So if you understand these things from problems 1 and 2, you did your job. Okay. Now you going through the rest of the problems, 3, 4, and 5, that's just you making sure that you really did your job. Okay. Number 13, let me just put 13 on here for my notes later. So number 13 looks like this. Oh, the retrieval. Okay. Okay, the retrieval, which is right there, right? 6, 7, this one right here. So the retrieval for this one, oh, you can fix it. I'm still looking at it. So the retrieval for these two right here, it's just asking for the slope. So when I'm asking you for the slope, right? If you look at this one right here, if you're asking me for the slope, I'm like, wait a second. I remember this equation. She showed it to me. Sorry if I'm making you dizzy. She showed it to me up here. It's this y equals mx plus b guy. Which number here, the m or the b, is my slope? In the chat, can you tell me which number here, the m or the b, is your slope? In the chat, can you tell me? Yes, yes, yes. Very good. So some of you said, Ms. Johnson, it's the M. Very good. So what I'm going to do is I'm going to play matching. Where is it? This guy. So I'm going to write it right on top. Y equals mx plus b. And then I'm going to play matching. Ms. Johnson, what do you mean by matching? Let me show you. So I'm going to write right on top, y equals mx plus b. Then play matching. So who is the slope? And in my brain here, slope is m. This is in my brain. She wants me to find the m. Okay, which one's the m? In the chat, can you tell me which one is the m, please? Yeah, it's just 8. Okay, so do you, Ms. Johnson, you just want me to write m equals to 8? Yes, sir. M equals 8. Very good. So this is what this person does. Pretty slick. Now look. Oh, look, I have more people answering. Very good. If you don't have this answer, please fill it out. Get yourself some credit. Let's go, people. Ms. Johnson, but you're just giving me the answers. Very good. Now answer them. Don't let it be on Desmos and not in your head. It needs to be in your head. Okay, next one. Here is how to find the slope. And I just made a video of this, so I will link it to yours as well. This is how you find slope, okay? I will link another video of yours. So here's how you find slope. Ready? So we're gonna go the formula and the equation, right? Let me just close this. Do you guys remember the slope formula? This is back in 7th or 8th grade. Do you guys remember the slope formula? Yeah, right? That's exactly why I show it though. Yes. It's also on this link is also on always in Canvas. Okay. So does anybody remember the equation for slope? I just did this in my other class too. Does anyone remember this? Tell me everything that you know about slope. How about that? Let's start with that. So we already said it's the letter M. What else do we know? Yes. Okay, so I got Dana and Nayeli. said rise over run. I love, this is one of my favorite definitions because it reminds me of what I'm doing on a graph. And hey, look, no shame. If you don't know the slope definitions, no problem. Just get these in your head. Okay, get these in your head. Write them on a piece of paper. Put it in your notebook. Put it at the top of your thing. Okay, yes, and the equation for slope, very good, Noah, is y2 minus y1 over x2 minus x1. I'm not a huge fan of formulas just because if you remember the formula wrong, you will not get the right answer. So I tend to use rise over run, okay? So for those of you who don't know how to find the slope here, this is from back in 7th and 8th grade. When you're finding the rise over run, you're just looking at the difference between rise and run. I'm gonna show you how to do this on Desmos's graph as well. So the first thing that I do is I just copy this equation right here. Physically do this. For those of you who are watching, stop, like watching me do it. You need to physically write this out. Okay, so on the top, you told me, Ms. Johnson, the y's. Yes, I also say the rise. So who's in charge of the rise here, the x or the y? Who's in charge of rise, the x or the y? Yep, it's the y's. So I'm going to put 5 right here, and I'm going to put his x right beneath him. Here's my 5, and I'm going to put his x right beneath him. So I'm taking this point, and it goes here and here. Okay, then who's in charge of the rise here? Well, it's -11. Okay, so notice here I'm changing colors, -11. Some people do this wrong, and they think that that negative right there is that negative. No, it's not. I'm supposed to be subtracting. So this needs to say minus -11. Ms. Johnson, it looks funny. That's correct, because you're subtracting a negative, right? So then I'm going to put his x right beneath him, and then I'm just going to simplify. So I get 16 over -8, which is just the answer, -2. That's my slope. If you're trying to graph slope, my thing is always make it a fraction, so it's -2 over 1. Okay, so for those of you who forgot what slope is, no problem. So if you have a point, right? If you have a point, random point in the graph land, just pretend you know where he is. And it's going to show up as soon as I refresh my page. You're going to go down to this direction here, just in my head. This is what my head is saying. Down to, oops, that doesn't look like down to, sorry. Down to right 1. Down to -2, right 1. Down to right 1. So really quickly, I want to show you in the land called Desmos. It's a good little land here. So when I go to Desmos, I can graph these 2 points. I can graph these 2 points. So let me graph them. So it's -2, 5 and -2, wait, did I do that wrong? Yeah, no, this is 6, sorry. 6, 11, wrong, 6, -11. There you go. Okay, so here you see, wait, you did see it. Where did it go? Where are you? There it is, right there, right? Here you see your 2 points. And here you're trying to find your slope between these 2 points, okay? So on a graph, remember, this is way back in the day. I'm going to annotate really quick. Back in the day, you would be counting the slope between these 2 points. I'm really looking for like how much to go up by how much to go over, okay? And hopefully this answer matches, hold on a second, matches my other answer, which is, hopefully my answer is the same, -2 over 1. Okay, so what I will do now is I will, let's see, I did not, I'm gonna get rid of this guy, hold on. I'm gonna go here, here, here. So here, I wanna connect these 2 and I wanna look for the slope. So if you remember slope, both Dana and Nayeli told me it's rise over run. So I'm gonna rise, change colors really quick. go with this orange. I'm going to rise. I'm going to go in this direction. I'm counting up here. Doop. And right here. Right? And I'm going to count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. I went up 16. So I'm going to type this out. I'm going to be like, hey, you are 16. I went 16 up. Boom. Okay. And then I'm going to count over. Hold on. Change colors, maybe blue. Okay. So then I'm going to count over all this. Okay. So now I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. 8. But because I went left, that 8 is -8. Negative because I went left. Got it? And then over here, they said to do the rise over run. So my slope for this guy is 16 divided by -8. Anybody see anything? Does anybody see anything? Anybody notice anything? You can answer. Just answer it loud. Nope, I don't see Miss Johnson. Or no, Miss Johnson, I don't know. I want you to see something.
I don't know.
Perfect.
A triangle.
Okay, good on the triangle. I want you to see something between our graph and our math. Does anybody see anything between our graph and our math?
The points?
Okay, good. So here's my points. They match. Okay, that's good. I do see that math there. I see, like, when you simplify this. Very good, Sarah. Sarah sees, I see both a -8 here and a -8 here, which is the -8 here. And,
Oh yeah, that's true too.
right? And she's like, hey, Miss Johnson, I also see a 16 here, which is a 16 here, which is a 16 here. These are the same two things. So I will always tell you, if you know how to do something one way, good. In math, I really want you to know how to do it in multiple ways. This is how you calculate slope algebraically, and this is how you calculate slope graphically. These two things are pointing to the same thing, right? So we were talking about chores that we don't really like. So maybe it's because you haven't found a different way to do that same chore and actually like it, right? So whatever it is. So if you are stuck at your house and you want to go to, I don't know, your friend's house, let's just say there was a roadblock here and you couldn't go. Do you know a different way to get to your friend's house? Hopefully, right? Maybe you go this way and then this way, right? Okay, so hopefully you see the connection. Very good, Sarah. Awesome, awesome work observing. And that's part of your job as a mathematician. Your job as a mathematician is to connect this to this, right? Okay, the other thing is, okay, but Ms. Johnson, I don't see this -2 business here. Well, let me kind of show you. So if I could zoom in, right? If I can zoom in and make tiny little arrows, these arrows are not going to be good. So I'm going to make one tiny arrow and then I'm going to point at it. If I go down to, looks like this. See how bad it looks right there? Looks bad, right? So I went down to, and then this says to go right one, down to right one. You see how I can, that's such a bad arrow, but don't judge. So do you see how I go down to right one and I hit the line again? That means I did a good job. That means I graphed the correct line. I simplified correctly. Are we all good on slope? Can I get thumbs up in the chat? I can't see your faces right now. So if I can get a yes in the chat. Okay. And then you guys said one more slide. I think this was actually this slide 13. Where are you? Where are you, Desmos? Yeah, that's slide 13. Okay, so I'm going to pause it here. We'll continue.